Alright, so in the last video we looked at our first of two special right triangles, the 45-45 90-degree triangle. And in this video we're going to look at the second of two special right triangles, and this is a 30-60 90-degree triangle. Alright, so to get an idea of how we get this one, it's actually a pretty straightforward process. Let's say I have a triangle and I label all of these sides 2A. And you'll see why I'm doing 2A here pretty soon. And so, what type of triangle is this? Okay, now if you have a triangle where all the sides are equal length, we know that's an equilateral triangle. Now, one other thing we know about an equilateral triangle is also that all the angles are equal. The only way to have a triangle where all the angles are equal and add up to 180 is if each of them is 60 degrees. So this is 60 degrees, and this is 60 degrees, and this is 60 degrees. Now, the next thing we're going to do is we're going to take this triangle and we're going to draw the altitude, or the hypotenuse, or the altitude, or the median, or however you want to say it. Okay, now in an equilateral triangle, when we put in this altitude, we end up with a right angle here. And notice that we take this triangle and we split it into two halves. So I'm going to draw one of those halves out here. Here's our right angle, and this length is 2A. And this here is 60 degrees, so I'm taking this right here. Now, if this length is 2A, the altitude of an equilateral triangle also is the median, so this ends up being A. And notice that the altitude is also an angle bisector, and we end up with here 30 degrees. So that's how we end up with a 30-60-90 triangle, is we essentially take a equilateral triangle and cut it into two, and we end up with a 30-60-90. All right, so let's go ahead and get this value of x. So this is a 30-degree, 60-degree, 90-degree triangle. Let's find value of x. So we start off with the Pythagorean theorem. A squared plus b squared equals c squared. And let's put in all our parts. So we'll call this a. So that's a squared plus x squared equals 2a squared. All right, so let's solve for x. We get a squared plus x squared equals, well, 2a squared is 4a. Subtract, or 4a squared, sorry. Subtract a squared from both sides, so you get x squared equals 3a squared. We take the square root of both sides, and x is the square root of 3 times a. And what we actually write is x is a times the square root of 3. So this equals a times the square root of 3. All right, so before we write out the theorem, let's redraw this whole thing. Okay, so if this is a 30-degree, 60-degree, 90-degree triangle, the length of the hypotenuse is 2a, the length of the shortest leg is a, and the length of the longest leg is a times the square root of 3. And so that is how we will write out our theorem. So this is the 30-degree, 60-degree, 90-degree triangle theorem. And this states in a 30-degree, 60-degree, 90-degree triangle, the hypotenuse is twice as long as the shorter leg. Whoops. Leg. And the longer leg is the square root of 3 times as long as the shorter leg. Okay. So let's look at an example of how this works. Okay, so we want to find the values of x and y. Okay, so the first thing we need to do is identify, is this a 30, 60, 90 triangle? And there's really not too many ways to, you basically have to be given two angles. You got the 90 degree, you got the 30 degrees, so by default that has to be 60 degrees. So the answer is yes. Okay, so let's go back to this figure here. So of these three sides, we have to associate one with a square root of 3, and one of them with 2a. Now the hypotenuse is always 2a, so that's usually easy to identify. This is 2a. And then the next thing we want is the length of the shortest leg is going to be associated with a. And the shortest leg is opposite the shortest angle, or the smallest angle, which in this case is 30 degrees. So this is a, which means this must be a times the square root of 3. So we know that a equals 5. So then y, which equals 2a, well, that's 2 times 5, so y must be 10. And x, which is a times the square root of 3, well, that is 5 times the square root of 3. And so there we go. We have the values of x and y. So the idea of the special triangle, especially the, the 30, 60, 90, and the 45, 45, 90 triangle, is, we're given this a equals 5, and then we can quickly get these other two sides. Let's try another example. Let's say we have this triangle here. We want to find the values of B and C. All right, so the first thing we need to do is we need to, label all the sides, whether they're A, 2A, or A squared root of 3. Well, first of all, is this a 30, 60, 90 triangle? Is this a 30, 60, 90 triangle? And the answer is yes. You got the 90, you got the 60, so the only way that can happen is if this is 30. So we have that. All right, now the hypotenuse is always associated with 2a. The length of the shorter leg is associated with a. Well, if this is the 30, that means this must be the shorter leg. So this is a. And so this must be a times the square root of 3. Okay, now to get b, we need to know what is the value of a. So we know that a times the square root of 3 equals 13. So we divide each side by the square root of 13. And so a is 13 over the square root of 3. Now you can't have a square root of 3 in the denominator, so we need to multiply by the square root of 3 over the square root of 3. So a is 13 times the square root of 3 over 3. All right, well, that's true. Then we know that b, which equals a, b must be 13 times the square root of 3 over 3. And then C, which is 2a, let's see here, that's 2 times, 13 times the square root of 3 over 3. Sorry about that. So C is 26 times the square root of 3 over 3. And so here are the two answers. So if there's a hard problem in this, it's the one I just gave you here, where this longest leg is some number, and then you got to go all the way around, and usually you have to divide by the square root of 13, the square root of 3, which isn't too bad, but you do have to rationalize that.